Have you ever wondered why your hair becomes hopelessly frizzy on humid days? Most people just attempt to drag a brush through it, fix it up as best they can, and when they get to school, tell their friends they're having a bad hair day. But do you know the exact science behind bad hair days? Your hair can actually be a creative way to measure the amount of humidity in the air. To do this, you can make a device called a hygrometer. Each strand of hair has an outer layer of flattened cuticle cells, which surround the fibrous cortical cells. The cuticle cells have a coating of specialized molecules that repel water. These molecules are called lipids. By repelling water, the lipid molecules help to protect the hair strand. The main proteins in hair are from a family of keratins, the same family of proteins that make up your fingernails. The keratin molecules in hair contain a large number of an amino acid called cysteine. The keratins bond to other cysteines, making hair strands strong and flexible. There are also many weaker bonds, called hydrogen bonds, between the keratin molecules. Hydrogen bonds can be disrupted by water, including water vapor in the air. This is what causes bad hair days. Hair will stretch as the humidity increases, and shrink as the humidity decreases. This is why hair becomes longer when it is wet, and shorter if it is dried with a blow dryer. Hair that is very moisturized is less likely to get really frizzy in humid weather. Hair that is often blow-dried or demoisturized is more likely to get frizzy. Question: how does the level of humidity on a dry day differ from the level of humidity on a humid day? Hypothesis: during a normal day, the humidity will probably be a little less than 50%. During a stormy day, the humidity will probably be about 70%. Procedure: pull 3 long strands of hair from your head. Make a solution of 20% rubbing alcohol and 80% water. Use a dab of this solution on a cotton swab to wipe down the hair strands. This will remove any residual oils. Cut the piece of plastic into a triangular shape to make the pointer. Tape a dime onto the pointer. Poke one of the nails through the plastic pointer near the base of the triangle. Wiggle the nail until the pointer moves freely and loosely around it. Glue the hair strands to the pointer, between the dime and the nail hole. Attach the pointer to the styrofoam base, about 3/4 of the way down the side. The pointer must be able to turn easily around the nail. Attach the other nail to the base, about 1 inch from the top of the base, in line with the pointer. Put a dab of glue on the top nail. Gently pull the hair strands taut so that the pointer points parallel to the ground. Glue the free end of the hair strands to the top nail. If the hair is too long, trim the ends. Dry the strands gently with a hairdryer until the strands no longer decrease in length. Mark this location as 0% humidity. Close up the hygrometer in a plastic box with a wet sponge. Wait 10 minutes. Mark the pointer location lightly, reseal the box, and wait another 10 minutes. Keep doing this until the pointer location is no longer changing. Mark the final pointer location as 100%. Measure the intervals in between 0 and 100%. Place the hygrometer outside on a humid day and a dry day and test how it responds to changes in humidity. Analysis. I answered my question, and my hypothesis was incorrect. I thought that during a dry day, the humidity would be about 50%, but it actually averaged out to 66%. I thought that during a humid day, the humidity would be about 70%, but it actually averaged out to 99%. I think there's a bit of a flaw in the experimental design, because apparently a rainy day in Mill Valley is just as humid as placing the hygrometer in an airtight container with a wet sponge for half an hour. Maybe I needed a more extreme humid environment to accurately mark where their 100% is. Conclusion. I built a hygrometer to measure the difference in humidity over the course of a dry day in Mill Valley and a stormy day in Mill Valley. I discovered that the experiment works. Hair shrinks in dry weather and stretches in humid weather, but that the hygrometer had a few flaws in accurate measuring. This is not entirely what I expected to happen, but it was cool to be surprised by the science of hair and humidity.